happens when the b value is smaller than 1, in between 0 and 1. You'll never have to worry about them being negative because that's irrelevant. A negative, we'll talk about that another time, but a negative sign would be attributed to the amplitude first, right? We're going to put a negative sign on the very front. We would never put a negative sign on the inside of these parentheses. Okay, now with 1/2 then, hopefully intuitively you can kind of guess that if we have a positive 2, we can see that this period shrinks, okay, by a scale factor of 1/2. So what's going to happen with this guy is the other way around. So let's see how that works. Again, I'm going to use my formula. Period equals, because I need to know the period. A normal period goes from 0 to 2 pi for sine, and so I have to change that up. A normal period would be 2 pi, but I need to take that 2 pi and actually divide by the value of b. Now, if I'm dividing by a fraction, if you remember that what it's doing here is multiplying by its reciprocal, okay? So dividing by a fraction is like multiplying by its reciprocal. So what I end up with is 4 pi. So this means the normal length that this of the wave from 0 to 2 pi is now going to be extended all the way to 4 pi. So to go back to here, this black wave here, a normal sine pi, sine of x, what happens is that I'm only going to see this front half. I'm only going to see the first half of the sine wave being stretched all the way from 0 to 2 pi, because the second half is going to be underneath here and going all the way to 4 pi. So if we label this 1 and -1, I go from 0, but 4 pi is way down here. So I know that this is my halfway mark. So this means I will reach my peak at pi. So all I can graph for this is a sine wave that looks like this. All right, that's it. So I'm done. There's nothing else for me to do because the only transformation that I have is just a b value. Now, if this was say, a 2 in the front, an amplitude of 2, I would have these anchor points, and instead of going to 1, I would actually go all the way to 2. So my volume would be a little higher, even though it's like the same note B, okay, or like the same F sharp, okay? So it's still an F sharp, but the volume of it has increased, okay? All right. So last one we're going to do is related to cosine. All right, so let's just see how it operates, how it functions with cosine. Let's say, I don't know, y equals, let's go cosine of 4x, okay? And actually, let's make it 4 theta so we're comfortable using theta as a variable value. Okay, so I have 4, and I want to write my formula. P equals 2 pi over b. All right, and my b is actually 4, so I go 2 pi over 4. Reduce the fraction, I get pi over 2. Okay, so I'm actually going to do the normal cosine. I'm going to graph him in yellow, and I'm going to do it here first, just to kind of you can see the effects of this 4 on cosine. Now, cosine is so very similar to sine, except he's just a little off center here. He's actually, instead of starting at 0, he starts at his peak, okay? And when he gets to 2 pi, he ends at his peak. All right. Now, there's reasons for why you would choose cosine over sine when you're dealing with an application, which we're going to get into next week. All right. Now, in the middle of this, okay, he starts from peak to peak. So the lowest point has to happen here. Now, let's label this +1 and -1. We're not playing with the amplitude at all in your homework, but I know cosine does this. He passes through 0 there. Here and goes there. That's cosine. That's normal cosine. In fact, I'll put him in yellow. Okay, that's normal cosine. But now that we found that the period is pi over 2, that means that a full cycle happens from here to here. So I normally will start here at the top, but my ending of the cycle will happen here instead, which means that my minimum value, my lowest value, has to happen right in the middle of these two endpoints here. So he will go all the way down to -1 here. Okay. Now I'm going to hit the middle somewhere in between, but that's okay. What I'm going to do is I'm going to carry out this pattern So it looks like 1, 2, 3 units. 1, 2, 3. I actually end the cycle. And right in between each of these, I actually hit its lowest point. Okay. And this is all I need to graph something that looks kind of cool. Okay. Not perfect, but that's all you can do by hand. Okay, so what we did is we made this sound, started off a deeper note and then actually got higher. Okay, the note actually got higher. Okay, got the pitch changed. Okay, so with that, I hope I spoke that. I hope I said that correctly. I'm not a musician, so I can never. Is a note is a different pitch or key? I don't know the difference between pitch and key, so I don't leave a comment in the comments. All right, but that's essentially it. Cosine is basically just like the same operations on sine. He just starts at a different location. So you can kind of see that cosine would be right here, right? If we were to continue this guy, cosine is actually sine, but he's just kind of like he's like shifted over a little bit. Okay, so it's the same principles happening. All right, that should be enough to actually do your homework and enjoy. I'm gonna go put my kids time out or something.